In 1806, the Prussian army was one of the fiercest militaries of Europe, but they had yet to face the flexibility and ingenuity of Napoleon's French army. I should say this one, not that one. Near the town of Jena, Napoleon commanded his army north. A general advanced troops upon the order of Napoleon to take a strong position in hopes of a decisive victory. The French lined up for battle on a hill overlooking the plains beneath them. 5,000 Prussian troops met them, followed by 15,000 more. Within the day, Napoleon's army would face some 40,000 Prussian soldiers. This would be no easy victory, but Napoleon ordered his men to advance aggressively and encircle the enemy. The Prussians, attempting to overtake Napoleon's forces in a momentary weak position, overextended themselves. The Prussians, a military rooted in deep tradition, would not deviate from the plan. Their leaders had little to no autonomy to be industrious on the battlefield. Instead, they were expected to simply execute orders exactly as stated. And the cost of that approach was steep. Within 24 hours, the French had killed 10,000 men and taken 15,000 prisoners on top of that. Napoleon's approach was novel, especially at a time where the term officer meant nobleman. There was the gentry and everyone else, the nobles and the farmers, the chosen, and the rest of us. Napoleon changed all that, but not nearly as dramatically as a collection of colonies in the New World. Within American military circles, there is lore about the controlled chaos of American troops in the battlefield, especially during the Second World War. A Russian document stated, one of the serious problems in planning against American doctrine is that the Americans do not read their manuals, nor do they feel any obligation to follow their own doctrine. A Nazi officer reflected, the reason that the American army does so well in wartime is that war is chaos, and the American army practices chaos on a daily basis. Now, the American response to this is generally, well, if we don't know what we're doing, they can't either. And honestly, I can't think of anything more American. Now, our work isn't exactly war. At least it shouldn't be. If your boss is behaving like a dictator, we should definitely talk about that and get you a new job. But I believe tech, in its relatively young state as an industry, has an incredible amount to learn from older disciplines. American tactics aren't exactly chaos. There is a sort of order, but these actions often do confound the enemy. They don't understand it because the context in which they operate is fundamentally different. The reason that our old world enemies considered our method to be chaos is interesting because it's not quite chaos, but it's something they just didn't understand. America has eschewed all forms of feudalism and imperialism, even as a British colony. Save for a few governors living large in London and a handful of short-lived, honest customs agents, colonial Americans could probably best be described as a band of smugglers. In the mid-1700s, a Philadelphia merchant named John Kidd estimated that out of 400 chests of tea that had come into Philadelphia, only 16 had arrived legally. 16! That's naughty. Americans have always had this sort of Wild West mentality, making our own rules, for better or for worse. And our military reflects this ethos by embracing a dilation of authority. Rather than every single person taking orders in a very strict hierarchy, our army instead chunks autonomy. Everyone from a general to a private exists in a parameterized hierarchy. They answer to a commanding officer, but they have room to be creative. As long as they operate within a set boundary of rules, they're free to operate how they see fit, make their own decisions, get a little weird. I'm Emily Freeman. I'm the author of DevOps for Dummies, and I am obsessed with helping engineering organizations create cultures in which diverse, collaborative teams can thrive. You can snag a copy of DevOps for Dummies on Amazon. I would love to hear what you think about it. need for distributed thinking didn't stop in the 20th century. In fact, I think it's extremely relevant to our work as developers and operations engineers. Now, if you know me, you know that I live and breathe DevOps. I love it. But I actually want to talk about what's next for DevOps and how we continue to evolve our thinking around engineering culture. You may think software has nothing in common with Prussian commanders, but I beg to differ. As a quick review, software was originally developed linearly and shipped, literally via the postal service, to customers. Remember when the internet came in the mail on a CD? That was fun. Aiml was great. Developing software was a lengthy process. Often years passed between the planning phase and the deployment phase. Now, you may think of waterfall as archaic and an abandoned methodology, but it's not quite completely in our past. While you can update software in satellites and spacecraft, you're probably going to want to get things right the first time, at least most of it. Failing forward gets a lot scarier when you're in an actual vacuum. Waterfall worked, but it was clunky. And like the Prussians, it left no room for adjustment or rethinking strategy on the fly. Then came Agile. In 2001, 17 software engineers met and published the Manifesto for Agile Software Development. This new workflow was a response to the frustration and inflexibility of teams working in a waterfall process. Working within these Agile principles, engineers weren't required to adhere to original requirements or follow a linear development workflow in which each team hands off work to the next. Instead, they're capable of adapting to the ever-changing needs of the business or the market, and sometimes even the changing tools and technology. Agile was the first methodology to really center the customer. It focused on delivering working software frequently and ensuring that the software provided value to the customer. Was it useful? This meant that changing requirements were welcomed, and engineers were expected to communicate with business stakeholders on a regular basis. Now, that never happened in Waterfall. Developers would be handed a binder of requirements from the business and were expected to implement them precisely as planned. Agile was the first time engineering teams really sat down to reflect on their performance and efficacy, what we think of now as retros or post-incident reviews. Although Agile revolutionized software development in so many ways, it failed to address this conflict between developers and operations specialists. It was an incredible step forward, but engineering teams continue to struggle with silos around technical skill sets and specialties. Now, at the time, most teams were organized by grouping developers and operations engineers separately. Developers would write the code and then toss it to engineers or operations engineers to deploy. Now, this created what's referred to as the wall of confusion. Developers had little to no understanding of infrastructure or how their applications actually reached the end user. And operations engineers had little to no understanding of the application code. That lack of awareness and collaboration is what DevOps aimed to solve. And I think we got pretty damn close. I define DevOps as an engineering culture of collaboration, ownership, and learning, with the purpose of accelerating the software development lifecycle from ideation to production. DevOps focuses on people, process, and tooling in that order. And the tenets of DevOps can best be summarized by a model called CALMS. Culture, how your team communicates and works with each other. Automation, how do you remove toil and reactive work by automating it? Lean, how agile or scrappy is your team at providing value to your customers? Measurement, how your team measures its success and effectiveness. And sharing, does your team freely share responsibility, ownership, successes, and failures? In DevOps, everyone that contributes to the delivered product respects each other's contributions and is aware of the motivations and constraints of other teams. And all of these people prioritize the customer over all else. In other words, how can we as a team best deliver high quality software to our users? The issue is that DevOps has become a catch-all term. Not only does DevOps mean 5,000 different things to 5,000 different people, we've added ideas to it. DevSecOps, MLOps, GitOps, AIOps, BizDevOps, DevDataOps, what? Like tagging things onto DevOps does not make it more DevOps. Honestly, I don't even know what the difference between some of these things are. I believe DevOps really has fundamentally changed our industry, and I'm proud of the work that we've done. We work more as teams. We've reduced silos. We think systematically, holistically. We've sometimes embraced failure. And we are much better communicators across the full process of delivering software. But our industry has fundamentally changed over the last decade. We used to go into offices. I mean, I wouldn't have been able to have the career I have living in Denver 10 years ago. I would have had to move to Seattle or San Francisco, but I get to work from my basement or my yard, sometimes my hammock, because companies have shifted to a remote first culture. That's amazing. In order to stay competitive, and often due to COVID restrictions, even the most office-centric companies have had to rethink their hiring. And I love that. So keep up the pressure. We've moved from monolithic architecture to a microservice architecture, where services are isolated from each other and communicate via APIs. Our applications are distributed on infrastructure across the globe to be geographically closer to our customers and reduce latency, or the time between when a user makes a request and your application actually responds. Our technical environment, tooling ecosystem, culture, it no longer fits into the original conditions in which DevOps was created. Now, when I first pitched this idea to a friend, I was met with some pushback. People are still adopting DevOps. People still aren't sure what DevOps is. Large enterprises and government agencies are still sorting out the details of adopting DevOps. Of course, I wrote DevOps for Dummies less than 2 years ago. I am not prepared to scrap DevOps and toss out anyone who isn't living on the cutting edge of tech. This is the technology adoption lifecycle created by researchers Beal and Bolin in 1957. And a version of it was popularized more recently by Jeffrey Moore in his book, Crossing the Chasm. Here's the thing. Yes, companies and organizations, even people, are still adopting and implementing DevOps because it's valuable. And the ideas and practices that DevOps embodies have incredible potential to improve collaboration, reduce silos, help engineering teams deliver more resilient applications faster. But I don't want to wait until the very last person in tech decides to get on the DevOps train to start thinking about what's next. Continuous improvement doesn't just apply to our systems. It applies to us too. We know that to stay relevant and honestly employed in tech, we have to constantly learn new skills, new tools, understand new frameworks. That's part of our job. That same learning culture applies to how we think about our people systems as much as it does our software. Now, confession, I would love to be able to tell the future. That would be very, very handy. But I am not a future or fortune teller. And I truly despise the term futurist. I think it's very silly. I'm not completely certain what the next phase looks like. But I have some ideas that I want to pitch you that can get the conversation started. Every country across the globe has a way of war, a unique style, a grouping of tactics unique to their culture, thinking, and priorities. Individual losses are not something acceptable by Americans. Our culture puts an extreme emphasis on the individual, and the outcomes of that are a mixed bag, as we can tell. But that's the way we are. And the military is no exception. We must win every time because the cost of life is simply too high to accept. Therefore, we over-index on investing in training and technology to leave troops over-prepared for battle. This extreme focus on training builds trust bidirectionally across the entire hierarchy. And this is critical to American hard power. Leaders have trust in their subordinates because they've seen them in action over and over and over again. which means when a sergeant is asked to clear a building, their commanding officers know that they will be successful. And soldiers, when asked to accomplish a mission, know that they're not being haphazardly sent to their death. This type of unwavering trust is unique to only a handful of militaries, seen almost exclusively in the Five Eyes countries: Australia, Canada, New Zealand, United Kingdom, and the United States. But it's trust that allows our soldiers to put all their brain power into the moment, into the mission. Across every branch, every division, every specialty, there are three main tasks everyone focuses on: shoot, move, communicate. Shoot, move, communicate. It's built into everything, repeated ad nauseum. This means budget goes to three areas: weaponry, transportation, and comms. With communication, I think, really being that linchpin. The other two can't happen without real-time, accurate communication across units. Now, you and I don't typically get shot at, nor do we live in retrofitted shipping containers, thank the Lord. But I do reckon that we should focus on three things too: shipping, iterating, communicating, repeating. What's the point of all of this if we're not delivering working software to our users on a regular basis, listening to them, thinking about the user experience? And once we get that feedback, the process begins again. We iterate, we adjust the roadmap, we prepare our infrastructure, we ship. But we have to do all of this in a distributed fashion, which means we have to think about this a little differently. I think we should take our cues from the bodies in which we sit right now. DNA contains the blueprints of how to make a human body. Well, any body, but in our case, human. With the exception of brain cells that rearrange their DNA over time, it's actually really fascinating, worth a Google search. Almost every cell in our body contains the same blueprint. But in utero, our liver cells know to become livers, and heart cells to become hearts, and so on and so forth. Differential or selective expression of genes is determined by genetic switches, referred to as epigenetic markers. These markers turn genes on or off like a light switch, kind of like a feature flag. And they're influenced by hereditary factors, diet, the environment. In a complex software system, I would consider these influential factors to be code, inputs or variables, and the environment, your operating system, database, infrastructure, etc. All of these systems, from the military to our bodies to our applications, are simply too big to manage from a single point of view. There is no way to think of it as one unit. Instead, I believe we have to break it up into smaller components, supply those teams with the tools they need, practice constantly, and trust that everyone will make the best decisions possible in the moment. One of the unintended consequences of DevOps has been this pressure or belief that everyone has to do everything, that a JavaScript developer has to understand the intricacies of the application CI/CD pipeline or the details of the cloud infrastructure. And on the other side of that coin, there's an extreme focus on developers lately that's left operations engineers feeling somewhat ignored, unsure of their role. DevOps is not a methodology that encourages everyone to do everything. That is asinine. We all have specialties, and we should lean into our personal strengths and professional strengths, leaning on others in our team to buttress our weaknesses. Calms define DevOps in so many ways by establishing tenets of focus: culture, automation, lean, measurement, sharing. Building on top of DevOps and Calms, I'd like to pitch SOAR: swift, observable, accountable, and resilient. The first principle is swift. Everything needs to be moving forward at all times. There's a flow to software development. And the trick is to think of it like water. Keep the water moving and keep it moving fast. This doesn't mean rush, nor does it mean to get sloppy. There's a saying in the Navy SEALs that slow is smooth, smooth is fast. So look for small improvements. This is where your measurements and data become truly critical. You must have a baseline on which you can compare to see improvement. Otherwise, this whole thing will be futile. Have you ever sat through an entire day of meetings and at the end of the day thought, what did I even do today? I didn't accomplish a single thing at all. You did, it just doesn't feel that way. And this is the same principle. If you don't have data to support your acceleration, you will not feel it. This is where I think SLOs and SLIs are extremely handy. A service level objective, or SLO, is a goal to describe a specific measure of performance to a particular service. These objectives describe what your team must deliver to ensure the customer is having a good experience with your application. SLOs are informed by service level indicators, or SLIs. This is a small, very detailed sample of a service performance taken at a very specific time. Optimize your goals to be clear, concise, simple. A great SLO would be something like, this service's response time will be under 10 or 100 milliseconds, 99.95% of the time, or an error rate under 2%. The issue with any complex system is you can't freeze it and study it holistically. As soon as you look at it, it's different because time doesn't stop for any of us. And from 1 second to the next, your system is different. What we can do is take samples of our system and study those to determine with confidence the state of the whole system. Our bodies are even more complex than our sociotechnical systems. And lab tests are a great example of sampling. If you have blood taken or your throat swabbed, a sample of cells is removed and studied, giving us insights into the health of the whole body. For us, SLIs are like those samples, tracked constantly to give us confidence in the health of the system. Part of being swift is removing blockers and bottlenecks across your team. A bottleneck is congestion or a blockage across a process. These are commonly approval processes, manual tasks. For example, a mandated manager approval or manual build or deployment process. Any handoff between teams can also quickly become a bottleneck, as some engineers are consistently dependent on others to continue their own work. One of the trade-offs we made when we moved to a distributed cloud-based architecture is we lost some visibility. We moved everything to the cloud, and there was this handoff of responsibility, which was awesome. Yes, we have to configure and optimize the infrastructure, but it's not like we need to maintain actual servers anymore or stress about environmental factors impacting storage and compute. That's someone else's problem. But that handoff of responsibility, we lost some observability in that, how things were actually running. It went into a bit of a black box, and that's mildly scary. Building on the measurements you use to implement a swift delivery of software, you'll want to gain as much useful telemetry as possible into your system. Now, this doesn't mean we can track every single little thing. We've always had to make these decisions, choosing what information to store in our logs versus what to let go, what behavior should trigger alerts versus what shouldn't. This isn't new, but these aren't decisions that humans should have to make on a daily basis anymore, which is why I think AI/ML is particularly interesting in this area. How can we train our systems to self-diagnose and alert us to issues or areas of concern before there's ever a user impacting incident? AppDynamics conducted a survey on AI ops in 2018 and found that 91% of enterprise companies reported siloed performance monitoring. In other words, service teams only tracked impacts to their particular area of responsibility. Now, that's not very DevOps. I hope it's improved over the last few years, but I'm doubting it has. We know that even in distributed systems, nothing is ever fully decoupled. And the intricate behavior of the system requires holistic monitoring, something machines are pretty good at if they're trained. Now, imagine being alerted that your load balancer isn't behaving correctly before a single server falls over, or knowing with confidence which services in your application to focus on and optimize because they contain the most transactions or the most impact on revenue. Finally, everyone in your organization needs access and training to these resources. They should not be reserved for only some engineers. So prioritize autonomy, chunk responsibility, enable your team to solve problems early and independently. I prefer the word accountable over responsible. Accountability is a willingness to account for your actions, whereas responsibility implies a level of control over a situation or a duty to deal with an issue. As a mom, I am responsible for keeping my child alive by providing basic necessities, food, shelter, clothing, etc. But the higher order role I have is to love her, to model the principles I value, to train her to be self-sufficient, independent, a functioning human. And that's where I'm accountable to my daughter. I make decisions daily, and I never really know if I'm choosing correctly. But I do know the information I used to make the decision and how I came to the conclusion I did. And when she's older, I'll be able to account for my decisions. And even in the cases where I'll have chosen incorrectly, I have confidence that I made the best choice I could given the data I had at the time. That's all we can do. And it's that concept that I think is a critical differentiator in reflecting on performance and incident response. We can say blameless until we're blue in the face, but it's an instinct of humans to throw someone else under the bus when we're stressed. That lizard brain back here, it has one job, and that's to keep you alive at all costs. When you feel fear, that gets triggered, and there's no way to unwind that adrenaline response. But I think if we shift the conversation from responsibility over an incident to accountability, it reframes the entire conversation. This accountability extends to your role as well, in that you're accountable for having an awareness and a respect of the work of your peers. You don't have to ever write a line of JavaScript to appreciate the language's capabilities and the choices that developers have to make. It's this awareness and respect that enables everyone to come together to the table as equals and contribute to the delivery of great applications. The final tenet is resiliency. I like to think of this as grit. I've always said that my greatest advantage is that I can take more hits and still get up than the average person. I've seen some stuff, and I've learned that the only path forward when you get knocked down is just to get back up. You don't have to pop up like an overcaffeinated gopher or a meerkat. You can take your time, but you have to stay in the game. You can't lose as long as you're in the game. So just keep moving forward, even if forward is a snail's pace. We've talked about resiliency from a technical perspective for years, mitigating disaster, practicing failure, chaos engineering, fault injection, ensuring services can recover quickly, accurately after an incident. But for me, I think the resiliency of a team is a fascinating topic. What causes one team to recover from stress while another collapses? Perhaps what's most fascinating about this is that the stimulus, the actual stress, it doesn't have to be big to be observable. Take two teams who receive free lunch at work, or used to. Tell them that free lunch is over. No more Taco Tuesday. It's done. Now, one team collapses into a frenzy of complaints, extrapolating the end of lunch to things like, will there be layoffs? Do you not value us anymore? Other companies are still offering free lunch. Are you going to adjust my salary to make up for this loss of compensation? This team ruminates on this, and it has no ability to mourn and then move on, to recover. The other team has a momentary adjustment, as is natural, but realizes that they can use the time to instead explore their city with their colleagues by organizing lunches several times a week. Same stimulus, vastly different reactions. I believe it comes down to psychological safety and group power dynamics. In order to build a resilient team, you must first grant people autonomy and trust. You have to train them to not only do their work better as individuals, but to do it better as a team. Practice may not make perfect, but it sure does make better. And I think some managers hear psychological safety and think they have to treat their teams with kid gloves. That's not true. Hard conversations around performance and expectations are part of the dynamic between a manager and a team. But you have to communicate expectations clearly if you're going to hold someone accountable. And you have to communicate your appreciation of their work just as clearly, perhaps more. People need to know that they're valued, that they have room to grow, someone has their back, and that they're safe. These are the characteristics of resilient teams and should be fundamental to your daily practice. In a distributed socio-technical system, you have to think of DevOps like DNA. Each component in your system, especially the human components, are like cells with epigenetic markers. They each carry all the information they need to implement DevOps, the trust, training, authority, autonomy, tools, but they can pick and choose what aspects of it best suit their unique circumstances at any given moment. Now, there's some nuance to this. I'm not saying that you get to toss key tenets of DevOps away just because they're hard. But what I am saying is that you can lean on the aspects of it that fit your immediate needs while maintaining an awareness, a respect of the people around you who work in different areas. I believe if we move to this distributed approach, we will build teams capable of delivering better software faster and more reliably. I think the next 10 years are going to be fascinating. I can't tell you exactly how it's going to turn out, but I have an idea of where we should start. And I'm going to focus on doing the next best thing. Our approaches and architectures and priorities continue to shift like sand, but through all of that change, I believe we're building something truly amazing. And I'm thrilled to be with you as we build it. Thank you so much.